this video is going to be on the topic of inequalities. Now, before we start looking at some exam examples, first I'm just going to go through what this inequality symbol here actually means. Well, this symbol here means that basically anything on that spread out side, or the right-hand side, is bigger than what is ever on the left-hand side, which is smaller. So if we were to put some algebra to this, for example, if I put an x on the bigger side and I put a number like 2 on the smaller side, that would basically mean that x, or any number, is bigger than 2. So I could have any number then that's bigger than 2, like 3, 4, 5, 6, etc., etc. Okay, so what happens if I do the opposite? What if I put an x on the smaller side and then I put a number like 5 on the bigger side? Well, this now means that x, or any number, is smaller than 5. So I can choose any number that's smaller than 5, like 4, 3, 2, 1. I could continue into 0, minus numbers. Okay, as long as it is smaller than 5, then that could be a solution for x. Okay, so let's look at this first example. Here I'm asked to write all the integer values of n that satisfy the inequality down below. So first, before we answer this question, we just need to go over a couple of key terms. So firstly, integer. So what does integer actually mean? Well, this is the maths word for whole number. So really, whenever you see the word integer, it's just asking for a whole number answer. Okay, so next we're just going to look at this inequality here. Now, actually what we've got here are two inequalities put together. To start with, we've got n is greater than -1. So that means we're going to have numbers that are bigger than -1. So we could have 0, 1, 2, 3, 4, 5, 6, etc., etc. We could continue forever. The second inequality we've got here is telling me that n is smaller than 4. That means we can have all the numbers smaller than 4, like 3, 2, 1, 0. We could go into minus numbers, and we could carry on that way. Now, because the inequalities are sandwiched together like this, we want the answers that are in both. And if you notice, the answers that are in both are these numbers here, which are 0, 1, 2, and 3. Okay, so before I ask you to have a go at the practice question, there is one more thing I just want to go over with you. And that is, what does it mean when there's a line underneath the inequality sign like we have here? Well, in this case, it means that the value -1 could also be included in our list of numbers, because this little line means equal to. So if you do see this little equal to symbol next to a number, it means you can also have it in the list. So that means that we also have this -1 as well as all of these other values in our list. Okay, so I'd like you to pause the video, have a go at this practice question underneath, and then I'll run through the answers in a moment. Okay, so hopefully you've had a go at this question here. So first off, the first inequality that we've got to deal with is this n being greater than -2. So that means I can have -1, 0, 1, 2, 3, 4, etc., etc. I could keep going. Now the second inequality here is telling me that n is smaller than, but also equal to 3. So remember, I can have 3 in my list because of the line underneath. And I've also got 2, 1, 0, -1, -2, and I can keep going smaller and smaller. So my answers are going to be all the numbers that are in both lists, which are these. So I've got -1, 0, 1, 2, and 3. Okay, so my second example, I am told that there are two inequalities in x shown on the number line. And I want to write those two inequalities out using the inequality notation. Okay, so firstly, you've noticed that we've got two blobs here, one coloured in and one not, pointing with arrows. Now the first one here, hopefully you can see that the arrow is pointing down my number line. It's pointing to all the small numbers here. So this is showing all of the numbers smaller than -6. Now the way we show that, if you remember, is putting an x, putting a little bit of algebra. Now this is going to be smaller than, okay, so we're going to put it on the smaller side of my inequality. Okay, and that is also going to be smaller than -6. Now if you notice, my other arrow is pointing up my number line, Okay, so this time x is going to be bigger than 1. So again, x is going to be written out. It's going to be on the bigger side of my inequality, and it's bigger than 1. Now, hopefully you've recognized that these two blobs being different colors actually mean something, and hopefully you have remembered back to the last example where we had different inequality symbols, one being equal to as well as greater than or smaller than, and one just being strictly bigger or smaller than. Now, if the blob is colored in or black, then we're going to have a line underneath. It's going to be our equal to inequality as well, whereas if it's just plain white or not coloured in, then it's just going to be a strict inequality. Okay, so my second example here is going to be one of those double inequalities that I had in the last example. Hopefully you can see that these are all the numbers between -3 and 7. So I need to show that x is bigger than -3. So if I put my x in the middle, to show that x is bigger than -3, it needs to sit on the bigger side of my inequality sign. And I'm going to have -3 on the other. And I've also got to show that x is smaller than 7. So this means it's got to sit on the smaller side of my inequality sign, and x is smaller than 7. Now, hopefully you remembered that if the blob is coloured in, then that means that it's equal to as well. So that means I've got to put an equal to sign in by that -3. So there's my inequality showing those numbers between -3 and 7. Okay, so what I'd like you to do now is pause the video again and have a go at these. Okay, so hopefully you've had a go at them. Okay, so the first one, if you noticed, it was a non-coloured in blob, and it was all of the numbers smaller than -1. So x is smaller than -1. The next one is a coloured in blob, so that's going to be equal to as well. And if you notice, all of the numbers are bigger than 4. So x is greater than or equal to 4. Okay, so before I go through the answer to the next one, I'm just going to highlight another property that you might have spotted. Now, if you put the x on the left-hand side of your inequality, you'll find that the arrow actually is pointing in the same direction that the inequality is, which can be a very helpful little tool to help you to answer these questions. Okay, so in the second one, we're looking for an inequality between -5 and 1. So x is going to sit in between here. Now we want x to be greater than -5, so that x is going to be on the greater side of the inequality, but we want it to be smaller than or equal to, because it's filled in, 1. So another type of question they could ask is for you to solve an inequality. Now, if you remember this word solve, we've come across before when it came to equations. And in fact, the technique for this is identical to how you solve an equation. The only difference is that instead of having an equal symbol, we've got this inequality sign here. So all where you would write an equal sign, you're going to write this inequality sign in its place. Okay, so to solve an inequality, I'm going to put down my two lines and I'm going to do some inversing. So first off, I want to get rid of this -5. Remember, I've got to get all the numbers together. So I'm going to add 5 to both sides. That's the inverse of -5. I get 3x in this inequality symbol instead of the equals. And then 13 plus 5 is 18. Next, I need to divide by 3. And dividing by 3 will give me just x. The inequality sign again instead of my equals, and I need to do 18 divided by 3, which is 6. So my answer here is x is greater than 6. Now it might ask you to show this solution on the number line. Now x being greater than 6 is going to be a clear blob, and greater than means I need to point up the number line. So that is my x is greater than 6 shown on the number line. Okay, so here's one for you to have a go at. I've made it slightly harder by making the inequality having a bracket in there instead. If you're not sure on this, make sure that you have had a little look at the solving equations video, but pause the video and see if you can solve this inequality and then show the solution on the number line. Okay, so the way I like to do these is to first expand the bracket. So I'm going to do 5 times x. And then I'm going to do 5 times 6, which is 30. Remember, I'm going to use this inequality symbol instead of my equals throughout this procedure. Okay, so now I'm just going to drop those two lines down, and I'm going to use my inversing. So I've got minus 30 to both sides, which leaves me with 5x on this side, my inequality symbol, and 20 minus 30 is minus 10. Next, I need to divide by 5, so dividing by 5 to both sides, I've got x is smaller than or equal to minus 2. So again, I want to show this solution on my number line. So x is smaller than or equal to minus 2 is going to be a filled in blob. And my arrow needs to be pointing to all the numbers smaller than minus 2, which is down the number line like that. Okay, so in my final example, I'm going to show you a more complicated type of solving inequality problem where you see we've got those two inequalities, that sandwich inequality system like we had in the first example. Well, actually what we're going to do here is identical to what we did in example 3. We're going to solve this equation, but what we're going to do is going to do two equations at the same time. So I'm going to drop my two lines down, and I'm concentrating on this 2x plus 9. And remember, I just want to get x out here. So again, I want to get rid of this plus 9. So I'm going to minus 9 from both sides. Now, minusing 9 from both sides gives me 2x in the middle here. Remember, I'm going to be using these inequality symbols instead of equals, and I've got two of them this time, so that 2x is sandwiched between these two inequality symbols. So now I need to minus 9 to both of these numbers. So start off with 1. 1 minus 9 is minus 8. On the right-hand side, I've got 15 minus 9, which is 6. So the next step, I need to divide by 2. And dividing by 2 will leave me with x in the middle here. Again, my symbols remain the same. And minus 8 divided by 2 is minus 4. And 6 divided by 2 is 3. So I've solved my inequality. But the question is asking me to list all the different integers that satisfy the inequality. So I'm not quite done. What I need to do here is just list the numbers that are bigger than minus 4 and less than or equal to 3. So bigger than minus 4, that means it's going to be minus 3, minus 2, minus 1, 0, 1, 2, and 3. Okay, so for the last time in this video, pause the video and have a go at this inequality problem. Okay, so again, the solution to this, I'm just going to drop my lines down, and I'm going to start by trying to get rid of that minus 9. So I'm going to plus 9 to both sides of my inequality. So plussing 9 to this 3x plus 9 gets rid of the 9, and the 3x remains in the middle. Put my inequality signs in. So starting off, minus 18 plus 9. Well, that's going to be minus 9. And 0 plus 9 is 9. Next, I'm going to divide by 3 to both sides. So firstly, that's going to reduce that 3x to x. Again, it's sandwiched between these two inequality symbols. Now, minus 9 divided by 3 is minus 3. 9 divided by 3 is just 3. And so I've solved my inequality. Now remember, this question is asking me to list all the different integers that are satisfied by this inequality. So here I've got all the numbers that are greater than or equal to minus 3, but less than 3. So I'm going to start off with minus 3. I'm going to have all the numbers bigger than that, so that's minus 2, minus 1, 0, 1, and 2. Okay, well, hopefully that's helped you to answer inequality questions. Again, practice by doing the exam booklet on inequalities. You'll notice that the questions are very similar all the way through, and just make sure that you're clued up on what this word integer means, what it means when the inequality has that little line underneath, and how to represent these inequalities on number lines, or even going from the number line to the inequality. Okay, good luck.